Hey guys, here's your next lesson, which is the beginning of chapter 5. And what we're doing is we're going to be verifying trig identities, solving trig equations, and using other types of trig formulas. This chapter should be fun. It's like doing puzzles. It's using this key, which is on page 650, which you should actually keep looking back. There's an orange box on page 650. It looks a lot like this. It looks exactly like that. And if you look back to that, that'll help you solve these puzzles. I'm going to do example 1, and then I'm going to do 3 problems from the homework, which I'm going to give you to try all the odd ones, odd and even ones really, because the answer is really the process. So the first thing is they're telling us that this statement is a true statement here, and they're asking us to verify it. So that's what we're going to be doing. We're going to be trying to verify that statement by using the identities that are on page 650. Now, one of the things that we can do right here is to understand that each of these things can be replaced, and we're only going to work usually on the left side of the equation, never on both. But we're going to try to make one side of the equal sign look like the other side by using these identities on page 650. The other thing, sometimes we'll work always on the side that looks more complicated, which is this side. So if you look at the secant of x, the secant of x is really 1 over the cosine of x. And then the cotangent of x, using an identity from page 650, is the cosine over the sine. Just like the tangent is the sine over the cosine is the cosine over the sine. And look, what we have here is 2 things that could cross out. They could reduce out, right? Not cancel out, but they're reducing out. And we get 1 over sine x. And 1 over sine x is equal to cosecant x, so this would be our last step. I'm being a little bit lazy here. I should write this each time. So what we did is we just showed that the left side of the equal sign is equal to the right side by using the identities on this page. Pretty easy. If you look at number 4 on page 658, which is where your homework is going to be, we're going to try 3 of these, and I try to pick 3 problems that were kind of different so you could see them and then try some on your own. But if I look in that box on page 650, I can see that the cotangent of a negative angle is equal to the negative cotangent. And you could actually, of the positive angle, you could actually play around in your calculator with some of these and see that these are true. And then this in your calculator would just be 1 over tangent, which would be the cosine. So this would be my first step in solving this problem, and I'm trying to make the left side come out to be a negative cosine of x. Using another property here, I could say that the cotangent, again, is equal to the cosine over the sine, just like in the first one. And you can see that these are going to cancel out, right? The sines are going to cancel out, and I have a negative cosine of x equals negative cosine of x, so I'm done there. Let's try 2 more. These 2 are a little bit different, or we'll just try 3 more. So this one, what we're going to do is we're going to do just replace the ones on the left, and we're trying to make this tangent and this cotangent look like a secant, cosecant, multiplied together. Kind of strange that an addition would come out to be a multiplication over here. But let's just replace the tangent with the things that we know that it's equal to, which is the sine over the cosine, and the cotangent is the cosine over the sine. And this should equal this in the end. This here is one of the problems where you actually have to use a common denominator to get it together. So the common denominator would be a cosine sine in the denominator. And I always ask myself this question: what do I have to multiply this denominator by to get the common denominator? A sine. So I'll have to multiply the top by a sine. So I'm going to get sine squared. And what do I have to multiply this by to get this? I multiplied it by a cosine, so I have to multiply the top by a cosine, and cosine times cosine is cosine squared. Then I got to look for another identity that maybe fits with this situation. And I could see from that page 650 that sine squared plus cosine squared is equal to 1. So I'm getting 1 over cosine theta sine theta. And since I want to show every single step along the way, I can almost see the answer coming out now. I'm actually going to say 1 over cosine times 1 over sine equals the secant times the cosecant. And then 1 over the cosine, my last step would just to rename this as a secant and rename this as a cosecant. I'm running out of space there. I hope that makes sense to you. So that's one where you use the common denominator. The next problem is this one with a cosine and a cotangent. And we'll just try to replace those as well. So this cosine t is going to be a cosine t over sine t, since the cotangent is equal to this from page 650. Keep referring back to that page. Kind of strange that it would look like this, but a cosine squared times cosine times cosine is a cosine squared. So it equals this 1 minus sine squared over sine. Now this cosine squared, if we look on page 650, they have that the sine squared plus the cosine squared equals 1. And if we just solve for a cosine squared by subtracting the sine squared onto the other side, look what we have. That means we can take this and substitute it in for the cosine squared, and we'd have exactly what we have on the right side. 1 minus sine squared t over sine t. So the two sides equal each other. Always working on one side. What the book is trying to do is they're trying to get you really used to working with these identities and even memorizing them so that you could use them for other things. This is number 26, which would be the last one. And let's see. What would we do here? We got to make this look like this. I think what we would do is change this tangent out and make it a sine over a cosine. And then what we could do is change this cotangent out and make the cotangent a cosine over sine. Because in the end, we want it to be this. Now this, if we have one thing, which is sine over 1, divided by sine over cosine, we could flip this one and multiply it up top. So we have sine cosine t over sine t. And you could actually see what's happening here. And this here is going to be a cosine t times sine t over cosine t. And you can see what's happening is that these cosines are going to cancel out, leaving us with a sine. These sines are going to cancel out, and effectively I'm going to get cosine plus sine equals cosine plus sine, or sine plus cosine. So these are 3 examples that you could look at over and over again, and I want you to try for your homework is if you go to page 658, there's a lot of these that you can do. But I want you to do as many as you possibly can, starting with number 1. Don't skip to the harder ones or skip around. Starting with number 1, you could do all the way up to number 60 if you want. If you want to do the odd ones, you can do the odd ones, or if you want more practice, you could do both. We'll be posting another video next week, and you'll have a quiz same day, same time, next Monday. So this lesson is just on section 5.1. Most of you did very, very well on your quiz that you took yesterday. So I wish you the best. Stay healthy. Bye-bye.